Hello, everyone. My name is Danilo. I'm a Kanban coach working for Objective Solutions. And today we're going to talk about different methods for being more predictable when delivering projects and also to answer the question when let it be done. So let's start. Uh, Again, Danilo working for 10 years of software development. For 6 years, I've been working with Agile. I'm an Agile coach consultant working with Agile development for the past 6 years. I'm a Kanban coach working for the past 3 years with exclusively Kanban, and also a speaker and a trainer of Kanban, Scrum, and Management 3.0. So today, I'd like to tell you a story about a project that I'm working on. And it was a project for a big bank. We had a 6-month deadline that we are committed to it, and we couldn't change that because we had some regulations around the software that we were delivering. And if we didn't meet that deadline, we would have like hundreds of thousands of dollars in fines. So the story is how we got to increase our throughput, increase our delivery in tenfold, and how we managed to deliver this project 1 week ahead of schedule. So for us, in this project specifically, predictability and the ability to forecast early was key. We needed that just from the start. But before I head into the story, I need to talk about some definitions. First is systems thinking. Systems thinking, as Don Meadows put it, a system is an interconnected set of elements that is coherently organized in a way that achieves something. This is a system. A system can also be composed of other subsystems. So you're talking groups of people and resources, group for a specific function, working together to deliver something. So system can be a set of systems, or you can just talk about a real small system. Okay, so when I'm saying, when I say that we put together business analysts, developers, testers, uh, operations, all working together, all working towards a goal, this is a system. This is my definition of a system. Okay, Little's law and its assumptions. So Little's law is an equation from Curing theory that Dr. Little proved to be very useful when you're talking about manufacturing, which is the average lead time of anything you're doing equals the work in progress that you have divided by the average throughput. So how does that work? We are talking about, in average, how much you deliver divided by the work in progress, how many things you have in progress, equals the time, the average time you have, the average time it takes to deliver. So Little's law, it's just this little equation, but what's most important is the assumptions behind this equation. So what do we need in our system for this equation to work? So predictability, also another important definition. Predictability for me is the degree of confidence which we can correctly predict a future state of a system or process. We are talking about how our system or how our process behaves, and we are assigning it a number, and so we know how stable it is, how predictable the outcome of this process it is. And we are doing that with a degree of confidence. So I'm not saying that predictability is just one number. It's a range. I can talk about how predictable my system is with 50% confidence or 90% confidence or 100% confidence. So this, we're going to talk a little bit more about this. For caching, I really like this definition from Troy McGinnis. He's a huge guy in the Kanban community. His work on for caching is unparalleled, and I really recommend you guys to follow him because he has a lot of resources on that area, which is really helpful for us working with software development. So he says that forecasting is about answering the right questions to a transparent degree of certainty with as little effort as possible. So there's a lot of things that are very key in this sentence. So first is with little as for effort as possible. We have a lot of methods to do forecasting. We have a lot of ways to do forecasting. And we have to find what is the easiest way for us to forecast anything with a high degree of certainty, not using much effort. Because we can go, we can use velocity, we can use linear regression, we can use average, we can use Monte Carlo simulations, we can use a lot of stuff. But what is the amount of effort that you need to do all those stuff? So we need to find the easiest way and have the highest degree of certainty on what we are forecasting using that method. So in the beginning, when I joined the project was 2 months in, and I joined the project because they needed help. And these are the 3 things that I working on at the beginning. So the first thing for me was an assessment. So I talked to a lot of people to understand what was happening. And for me, these were the 3 key things that we had to work first. First thing is define the system. So where our system begins and where our system ends, where are the boundaries, where is the handoffs, right? So if we have this information, we can start collecting metrics that matter to the project. Because the way it was so confusing that the metrics didn't make sense. Any number that we got from the system didn't make any sense. They didn't have a backlog structure. They were using user stories, but it didn't go further than that. And that also doesn't help us collecting metrics to understand what is happening in the system. So I sat with them and we defined a backlog structure to make sure that we know what size is for every part of that process. And we would know what is the size of the features or the user stories or the tasks that the team could put inside their own system. And we could measure this. Variability. So variability is analyzing how unstable the system was, how much variability we had within the system. And I noticed that we had a lot. So there were days that we didn't deliver anything, and then there were days that we delivered a lot. And this is not good for the process. This is not good for predictability. And we had to at least talk about it. And also, I said to them, so let's try this crazy idea. So let's try to do all of this without estimating anything. And they said, yeah, this is not going to happen. Why not? So why can't we try this? So they were very resistant at the beginning to do no estimates. So I said, okay, so let's keep doing plannings and estimating all of this, but I'll be measuring this, all the estimates, all the deliverables, I'll be measuring this, and then we're gonna talk about this in the future. So this was my proposal, and they said, okay. So we started with no estimation, but the principle of stabilizing the system and making the system more predictable, this was clear for everyone. Estimating or not estimating, we had to do this. So we started this. They started estimating. They were estimating. So I got all this data, all the story points they're using, and I compared against the cycle times. I compared against the time things got delivered. And when I showed this to them, they were very surprised because we saw that things that were estimated in 8 points or 13 points sometimes were delivered faster than the things they were estimating as 1 or 2 points. If you think about it, it should be like a ladder. You start with 1, which are the very easy things, and then you deliver this quickly, and then the other things that are more complex and requires more effort should be delivered. It should take more time to be delivered. And it wasn't like that. So there is no correlation. And when I said that, okay, so if there is no correlation, things you deliver, you estimate with 13 points gets delivered faster than the things you deliver, you estimated with 1 point. Why you are estimating? And I said, okay, you made your point, so let's try this. And then we started for 3 weeks. We wouldn't estimate anything. We just do the work and prioritize everything. So define the system. What is define the system? Like I said, from system thinking, we are talking about systems or a set of systems working towards a goal. This image is from the Upstream Kanban book from Patrick Stayard. I think that's how you pronounce his name. And I really like this image because it shows us a system end to end from the beginning, when you suspect that you have a need, when you have an idea or a customer is requesting something, until you get this delivered. So this is the whole system. There's a lot of things that are happening here, a lot of people involved. And I showed this to them that this here in this column, ready to start, or in our case was backlog, is the beginning of our development system. So this is our Kanban system, as per se. And at the end for us was deploying to production, because we had control over the whole process. We didn't have an operations team and a support team that do deploys for us. We were able to do this. So our system begins in when the analysis was done, the feature is created, and it passed to development until we deploy it. This is where our metrics work, and this is what we are measuring. So all the metrics I'm going to show you guys in this presentation is from this system. I'm not looking at the end-to-end flow. We weren't working on that level. We were just working on the team level. Backlog structure. So like I said, they had user stories, which are very small tasks. There's a lot of things that, a lot of different sizes, and also the business needs for that project we weren't looking at it. So with the backlog structure, we define it this way. We have a demand, which you can call it epic as well. So this is a big demand. This is a business requirement. It's very big, and it takes months to be delivered. And we have features. Features, for me, it can be the same as user stories. So a feature is the actual deliverable. So a feature gets delivered to the client and represents a certain value. The subtasks are the development tasks. All tasks that the development team, the testers, and anyone had to do to complete a feature, this is a subtask. So if you think about a funnel, the demands are the high level, very big, and sometimes vague because it's big. And we have features, which are deliverables, usually an action, and then you get the subtasks. And the third thing was variability. So what is variability? This is one way we can track. This chart shows me in the vertical axis the amount of things we delivered, and in the horizontal axis, it's calendar days. So I can see that in right here, we deliver 5 things. Here was like 8, and here was 22, maybe here 21, and then it goes back to 8. So it varies a lot. There is no constancy. It's not consistent. And here in the green line, you can see the moving average. So the moving average is also not consistent. It varies a lot. This is not a predictable system. This is not a stable system. A stable system is where this moving average is like a straight line. It doesn't change. And for sure, we know that when the next delivery is gonna come, because it doesn't change. Okay, so these are the 3 things that I did at the beginning. And the next thing was cleaning house. So what I'm calling cleaning house, this is our task board. This is how we visualize things. We have all 3 levels here. We have demands, we have features, and we have subtasks here. So I can see everything that is happening in the project. And cleaning houses, we are updating, we are deleting, we are canceling, and moving tickets to reflect the reality of the team. We use Jira behind this task board. This task board is a task board that we created and is integrated with Jira. And we were moving tickets in Jira to represent what is happening at the project. And we install like a ticket updated discipline. So we had to update the tickets. We had to make sure that every ticket was in the right stage, because our metrics. We're counting on it. So we have to be very diligent on how we are updating the tickets and where the tickets are. Okay. Right after that, I can start talking about the assumptions behind Little's law for Little's law to work. And the first assumption is measure cycle time, work in progress, and throughput. These are the things I was measuring, but what the assumption says that all the things you're measuring must be measured in a consistent way, must be consistent. And that means if you're using days, you should be using days for everything. You're using hours or using users, story points, you're using t-shirt sizes, whatever you're using, you have to measure everything in the same unit, because if you mix that up, you can get into trouble because it will be harder for you to read your data, and even you can take decisions based on bad data because of that. So in my scenario, I was measuring everything in days. So we have cycle time is measured in days, throughput, the count of units per day, work in progress, the amount of units we have in progress per day. And I can show in these charts here. So the first one at the top, this is our daily WIP limits, daily work in progress actually. So here in the vertical axis is the amount of things in progress, and here are the calendar days. And we can see that it varies a little, especially this one that it comes to 12, but it doesn't change much after a while. And we are stabilizing the system regarding we work in progress because we limited the WIP, but I'll talk about that later. This one is called a scatter plot. And here we have the amount of days that it took something to be completed, and here calendar days. So it means that this little blue ball here tells me that an item, a ticket, will take like 28, 29 days maybe to be delivered. And most of the things were delivered in less than 10 days. So this is what this is telling me. This 95% here, this line here, tells me that 95% of all the tickets completed, all the items completed so far was done in less than 8 days. This is what this chart is telling me. Oh, okay, so all in days, and I was measuring cycle time, throughput, and the amount of work in progress. The second assumption, it was the average arrival rate should equal the average departure rate. So what was the problem? The problem was still too much variability. We still had, we didn't have any control over the process. So what we did is we installed WIP limits. And WIP limit means that, for example, in this scenario here, from moving the column from the column planning, when you're doing actual planning, from the to dev, which means this column means that it's ready to be developed, we installed the WIP limits of 5. So we couldn't have more than 5 items here. So this was the first step. We didn't have any control of how many things were entering the system. And we had to do something about it. And then we installed WIP limits in the whole process. And this is an example. So we are saying that we can't have more than 5 items here. And for an item to be passed to developing, we had to have a space here too. So we had WIP limits for every column, and we couldn't get more things into those columns after we arrived at the WIP limit range. Okay, and this is shown right here. This is a cumulative flow diagram, the CFD. There's a lot of information on the internet how you can read this properly, but what I want to point it out is that every color here is a stage of our process. This can be like was in the backlog stage, development stage, and also the big blue here is done. So everything that is completed, this gets here. So this is why this is increasing, and all the things that is in progress, it's shown here. So since we had like a very strict WIP limits. These are not too big. And these lines here represents the average input rate, arrival rate, and departure rate. And at a point in time, we get them to be very, very similar. So in average, we have 5 items per day entering the system, and we had 5 items per day leaving the system. So this is the second assumption. It means that what is deciding what enters the system is the output of the system. So we are not pushing things into the system. We are pulling things. If we have capacity, we are bringing them in. If we don't have capacity, they stay there in a queue stage column in our process. So third assumption, all work that is started will eventually be completed and exit the system. So in this case, we don't have discard rate. We don't have things that get deleted from the system. What it means? What it means is things don't just disappear, right? If we pull something to development and we believe that this were not gonna be done anymore because of priority change or whatever you you want to call it, we can cancel it. And what this means for the process is this goes to the done column, and we put an observation saying this was canceled because of X, Y, and Z. This way, we are protecting the flow, we are protecting the system, we know what is happening, and also know how is our cancel or discard rate in the development process, because we have this information. So what we did is we had the cancel and discard rate for us was too high. So what we did, we implement some policies to have better features being put into development. So we talked to all the guys, and we implemented acceptance criteria. Actually, the definition of ready of a feature for development was set, and this was a policy, agreed with everyone. So we decided, okay, so the definition of ready for the feature is to have the acceptance criteria, a description, understanding of the business side of this feature. If we had to have mockups, we did it, and we did all the things. And developers were empowered to reject features that wasn't in that state. So this is a policy as well. Right. And with this, I can show you this chart with this. This is our throughput histogram. And what it says is here we have the amount of things we delivered. And these are the amount of days that it took for everything to be delivered. So what I'm saying is that here we have like 50% of our of all our data, of all the things that we have delivered, 50% was delivered in 3 days, and 95% of everything was delivered in 22 days. And we have some things here that go beyond 95%, but they are very small things. They're very, there isn't a lot. And what I did after that was to analyze if we have any outliers here. But what I'm saying, what this chart help us is to see that which kind of percentage and the number of days it took to deliver, and we can start making at least SLEs, service level expectations with this, because we know how our system is behaving. I know that with 85% something will be delivered in 9 days at this point in time, and I know that it's almost certain, it's 95% certain that something will be delivered in 22 days. So using this assumption behind it and making sure that everything goes to the done column, I can see in this chart, and I can remove the things that had been canceled or discarded from this chart to see, okay, so what was delivered, and if the things that wasn't delivered, they were canceled, where they are and why that happened, and then I could take some action on that front as well. So, fourth assumption, the amount of WIP should be roughly the same at the beginning and the end of the time interval chosen. the time interval chosen for me was the whole project, and the amount of WIP should be roughly the same, right? And we know that in manufacturing, this is a reality. We can have you. It's easier for you to have the same amount of WIP, but in software development, it's not that easy. So the thing we did to make sure that we are predictable is first making sure that we know that the priority that we have is the one that we actually need to have. So many things were done in that regard to make sure that the highest priority items, as they are at the top of the board, and the lower priority, the less valuable things are at the bottom. And that means that doing this, we could use a Q discipline named FIFO, first in, first out. So everything that comes into this column to dev here, if they're on top, they are the priority. So the developers cannot and they cannot choose what they're gonna pick next. They have to pick the first thing at the top of the column. So we created this discipline for these columns, the two columns, because they were buffers. So there is no work being done here. These are just columns for us to map what is waiting to be done. So here is what is waiting to be developed, and here was waiting to be tested internally. And doing this, I was also at the same time measuring the work in progress. So here, the same chart I showed you before, number of items in progress, calendar days, and this is the moving average right here. And because we installed WIP limits, we can see that it varies, but it doesn't vary much. If you look at the scale, this go from 0 to 12. So 12 was our WIP limit, and the moving average, it doesn't vary much. If you look at if you look at the whole chart, it doesn't change much, right? The variability in the beginning was way bigger than that. We had days that we have WIP work in progress. If I'm not mistaken, was 40 or 35 items for a team of 9 people, and now we have 12. We had 12 at the time. So we had WIP limits, and we had work in progress under control because of WIP limits, and that made our system more stable. So number 5, the last assumption is the average WIP age is neither decreasing or increasing. What does that mean? That means that the things that get in progress, they take a certain amount of time to be completed. Let's say, for example, 5 days. And if you measure this in the next week or the next day, this number shouldn't change. So if it is 5 days, you have to make sure that it's 5 days always, for example. And this is the chart that I use to measure this. This is WIP aging, it is called. And here we have the amount of days, and here we have the stages in our process. So I know that every blue ball here is an item, is a feature, and how long they are in progress, because we started to plan and we finish on QA. This is progress. The done column is when it is completed. And here I know how many days is in progress and if it's reaching our limits. So at that point in time, our 85% of things that we delivered were delivered in 39 days. So this was this was our 85% at the time. So what I did is I look at this chart and see, okay, this guy here, these 4 items here, and this guy here is getting closer to the 39 days. So why we are delaying it? This is in progress. Why we are delaying it? Maybe get deprioritized. Maybe it's bigger than we thought. Maybe the guys are having technical problems with this. So because of this chart, I could take actions on those guys and talk about it and analyzing them to make sure that it don't go over this line. This is a definition from Klaus Leopold. He is also a great guy in the Kanban community. He has written a practical Kanban. He wrote this. The prerequisite for minimum forecast is a stable system, and that is a system in which work in progress is limited. I cannot stress enough how powerful WIP limits are. WIP limits was the most important. Okay, and this is a timeline of the stabilization of the system. This is where we begin. So we started when I joined the team and I did an analysis. I got this number. So we had 0.8 things entering the system and 0.4 things leaving the system, and we have a WIP age of 70 days. So bottom line, nothing is getting in progress, nothing is leaving the system. It just all sits there, and this is not great for us. A WIP age of 70 days is a lot. So we started implementing all the things I showed you, um, some of the things I showed you, and then I analyzed it again, and our arrival rate was 2.1. We are delivering 1.9, and the WIP age was 49. So a little bit better, but not enough. So we keep doing the changes. We keep persisting with increasing our throughput by work in progress, better prioritization, better visibility, and we got into this place where we had 4.5 items um, entering the system, 4.4 leaving the system, and a WIP age of 6 days. So that means that things get into the system, it didn't leave after 6 days. And we are delivering 4 items and we are getting 4 items. So this is where we got to have a system stable, because we are balancing demand against capacity. The way that we were not we're not pushing things into the system more than the team could afford, and we are, because of that, we are delivering more stuff. So we got from 70 days to 6, and we got to deliver nothing to 4 per day, which is a lot and help us a lot in this process. And to do forecasting, so we use Monte Carlo simulation. So what is Monte Carlo simulation? It's fairly easy. You get a data set distribution. Let's say that my distribution is the amount of tickets that I delivered, and they have a range. They start with an example is the item I delivered, the quickest I delivered was 1 day, and the longest were, if I'm not mistaken, 65 days. So I have a from 1 to 65. This is my range, and everything that I delivered was inside that range. So Monte Carlo simulation, what it does is it gets the minimum and gets the maximum, and does a lot of simulation between those two points in time. And it creates new numbers. And we did this like thousands, millions of times. And then we get a number. So for us, it was like this. This is the Monte Carlo simulation using 1 million trials, using the data set from our project. And it gets a shape like this. This is almost a Gaussian distribution. It's not, it's a little bit, it has a long tail here. And I did this every day, and I look at these numbers every day. And this tool here, Actionable Agile, gives me this calendar here using the percentages that Monte Carlo is giving me. And with 85%, I knew that we are going to deliver the project on the 10th of June with 85%. So it could be between 10 and 19. In this project, the deadline for this project was 28, if I'm not mistaken. So when I got this number, I said, okay, we are on track. If we keep doing the things that we are doing, we will deliver this project on time. And the brilliant part is I discovered this in April, in the beginning of April. So I joined the team in February, and we did this in February, March, and in April,
I knew that we are going to deliver the project within the deadline. And what this information done for us? Um, uh, I said to the guys, okay, so we are online, we are in our deadline. So let's keep doing what we're doing and improving from this point forward. So we knew we were on the right track, and we knew this in April. So we had April, May, and June to improve our system. And at the end, we delivered the project in 8th of June. Sorry, not 8th. It was 11. 11th of June, we delivered the project. And so what I did is every day I measured those numbers. I look at the Monte Carlo simulation and see if it had any variation. So did it improve? Did it got worse? Uh, it moved from the day 15th. Why did it move? What happened? So did it got any problems? That's because we are postponing the date. It gets better. It goes to the 3rd of June. Why was that? Why we did that? Shortened the timeline. So we discussing these things and how you do it. So there's a lot of ways that you could do it. For me, I was doing two things. In the Monte Carlo simulations, to know how you're going to deliver, you have to know your backlog. And we had this information. I had the remaining backlog, the amount of things that are needed to be completed. And I was using this for a while. And then I said, our backlog is growing. There are some things that get introduced into our backlog from time to time. So I started using the backlog growth rate as well. So it's using remaining backlog plus the rate my backlog was growing. And this is what I use to put in the Monte Carlo simulations. Other things you can use, you could do is class of services. You can separate the backlog in class of services and do Monte Carlo simulations for each one of those, or working item times. You can use the same, like what is my my delivery rate using Monte Carlo simulations for bugs, for features, for improvements, for refactorings. You can use in a lot of different ways. So this was crucial for us to understand how our system was behaving, how we are working together, and the simulations were used to test different possibilities using different backlogs. So let's say that, for an example, I had 100 items to be delivered. So I put 100 items in the Monte Carlo simulation to see when we are going to deliver this. But the discussions around the backlog, to remove things or to add things, we use the simulations as well. So let's say that we are going to add another 20 features because we have another need. Okay, so let's simulate that. Let's remove 20 items. So now we have to deliver 80 items. Okay, let's simulate that and see where the date, where we stand. So we use this a lot, and it's a very powerful tool for forecasting deliveries. So bottom line, forecasting is about asking the right question. So for us was, are we going to deliver this under the deadline that we have? This is the question for us. Predictability is the degree of confidence we can answer that. So like I showed you, for us, predictability, I look at the chart and I say, okay, so 95% of my whole distribution of all my deliveries are delivered in 22 days. So when I'm going to finish my project, so Monte Carlo simulation does that for us using this data. And I know with a degree of confidence. For me, most of the time I was using 85%. I always use 85% because it has a high rate. And in the beginning, the difference between 85% and 100% was more than 30 days because there was a lot of variability. And at the beginning, wasn't that much. I think it was 6 or 7 days. I could use 100%, but I was using 85 because it's a high degree of confidence. So for caching, what is the question you're trying to answer? And predictability is how you're going to answer it, right? So to finish this up, how you can use all of this that I showed to you tomorrow in the next day of work. First thing is define your system. You have to know where are the boundaries, where your system begins and where your system ends. If you don't know that, it'll be harder for you to measure and to those numbers to make sense. Second, measure cycle time, throughput, and work in progress. So cycle time, how much time it takes for a thing to be delivered. Throughput, it's how much you are delivered, how many items you are delivering. And work in progress is how many things you have in progress. Again, WIP limits, it's, it's principle. You have to do it. You see the difference when you limit your work in progress. There's a lot of ways you can do it. Most popular ways that I know from the community is you the number of people in your team plus 2, so you double it. Another way is 1.5 times 1.5. People do that as well. And one thing that I like to do is when I get to a system, when I get to a team that the work in progress is high, the WIP limit is the number of items we have at the beginning, and then when they deliver something, I reduce one item. So I'll keep reducing the WIP limits one at a time until we get to a number that the team feels comfortable. So it's mostly empirical. We can do an analysis saying, we are reducing work in progress and our throughput is going up, our cycle time is going down, and then it can come to a point where work in progress, you reduce so much that you created a bottleneck, and you're going to see cycle time going up, you're going to see throughput going down, and and that's because of work in progress. So you kind of have to test it and see what works for your context. Fourth, use Monte Carlo simulations. Monte Carlo simulations, they're good because you can test a lot of things. You can simulate other scenarios, different scenarios for your process, and see if that works for you. And then you can create some actions based on those scenarios that you simulated. And again, rinse and repeat every day. So forecasting is not about that plan that you do in the beginning of the project and then you look at it at the end of the project and see, okay, did it work or not? Forecasting is you have to do it every day. Every day your system changes. Every day your system or your team or something will happen that will change the behavior of how things are happening. And you have to make sure that you're looking at it, you're analyzing it, and these tools will give you a way to make sure that you're on top of it. I think that's all I had for this video. I hope you enjoy it and see you next time.